afternoon, LunchMAR. It's a pleasure to be here again. Today, we have the pleasure of hearing from Catherine Dlubak and Stephen Springhorn about DWR's Basin Characterization Program. You might ask, well, haven't they already done that? Well, they've done an incredible amount of work collecting borehole data and the AEM data, and they've done a wonderful job of presenting that data and making it available. And what's left to be done? Well, actually, there's quite a bit to be done. Imagine your doctor is diagnosing you mainly or only with the X-ray or CAT scan, but without much knowledge of human anatomy and physiology. They have to integrate all of that. So think of the AEM and the borehole data kind of like the X-ray and maybe the blood samples, but those need to be combined with current geologic information, the origin of the deposits, the aquifer systems, to paint the whole picture and to make the system more transparent. Much of that has been done, but it turns out there's much more that could be done to make the invisible visible. Catherine Dlubak is a senior engineering geologist in the Sustainable Groundwater Management Office at the California Department of Water Resources. She is the project manager for DWR's Basin Characterization Program and supports the implementation of the Sustainable Groundwater Management Act. Stephen Springhorn is a program manager in the Sustainable Groundwater Management Office. At DWR, he oversees technical assistance and aquifer characterization activities related to California's Sustainable Groundwater Management Act implementation. It's a pleasure to have these two with us today, and let's get going. Stephen and Catherine.
All right, good afternoon, everyone. Thank you, Graham, and thank you, Megan, for opening things up. We're really excited to be here with all of you, building on Graham's analogy, the connective tissue of basin characterization in California. So we have a great presentation to go through today, but I first wanted to start by acknowledging, first off, Graham, thank you for being here today and facilitating today's discussion, but for all the decades of work that you have done throughout California and really have been championing basin characterization, the exchange of ideas, research, and practices across the state. So it's really great to have you here as we launch this new exciting Basin Characterization Exchange. And also wanted to do a special thanks to you and Rosemary Knight from Stanford and others that were instrumental in us procuring funding back in 2014 and 15 that allowed us to do these statewide AEM surveys that were really the catalyst for all this new action momentum in California, and really a change in mindset of the importance of our groundwater basins and how we can really understand them better than before, and then really the requirement to utilize them in a sustainable way like we never have before. All right, so, and then finally, I want to acknowledge our great team that's cranking away and working on all aspects of this basin characterization program, from internally within DWR, our headquarters office, as well as our regional offices across the state, and the great external team, contractor team we have that has been working with us along the way. So what we have in store today is we want to go over some of the just setting up the framework for Basin Characterization Exchange, some of the overarching goals that we would want to achieve, and really building off of the great network that is in place with the LunchMAR network and the LunchMARs that we're really excited to be co-hosting this launch of the BCX with LunchMAR and the LunchMAR network. And we strive to partner with the LunchMAR network and really grow and really take a lot of input from the LunchMAR network, because that is such an important connection we have. And a lot of the work that we're doing is driven by the need to understand groundwater basins for managed aquifer recharge, for LunchMAR, for different ways to get water back into the ground in a responsible and sustainable way. And then I'll quickly talk about some of the connections of this work, our characterization work, to other initiatives we have going across the state. And then I'll hand it over to Catherine to go over the latest on the statewide AEM surveys and data availability, then go all into the characterization program and all the new exciting information that we have going and are planning to do in the future. And then finally wrapping up with looking at what's coming ahead and some opportunities for engagement. So along the way, please use the chat function, ask questions, throw your ideas in there, because we are really trying to launch this with that spirit of collaboration and sharing ideas and working together. So I know this group, probably many of you know basin characterization really well. And just to sort of level set with all of us, why are we doing basin characterization? Well, number one, we're required to do it in the California Water Code, but there's also all these other reasons why we need to do it for sustainable water management in California moving forward with the different pressures we have on the resource and the changing climate that we know we're seeing now and we expect more to occur going forward. So it's really this effort to understand our natural infrastructure, our groundwater basins in the state that have a tremendous potential. They're used now, but we know that there's tremendous additional potential to use our groundwater basins, our biggest form of water storage in California, and our biggest form of natural infrastructure in California. And so we really want to be doing this in this realm of all this new management, existing and new management that's needed to manage groundwater sustainability, to protect the natural infrastructure, our groundwater basins, and those things that rely on it, and have that integrated water management and resilience in California, to be able to be prepared and planning for those extreme shifts from very wet to very dry, and everything in between. So the quote there at the bottom, really, the past is the key to the present and future. It's sort of a flip on a famous geologist quote, but it really is the better that we know how these different sediments were deposited and are arranged in these basins across the state, the better we know how where they are going to show up in the subsurface and how we can utilize that knowledge to optimize management actions and promote sustainable management. And so it's going to really help understanding the groundwater basins and how they were deposited, as Graham mentioned, to then understand how presently we can utilize them in a sustainable way and then keep doing that in the future, as we know we have to have this more dynamic management going on. So again, why the BCX? We're really excited for all of you attending today and everyone else that we can really bring into this community of practice. We are really trying to make this open and a collaborative space to exchange ideas, share lessons learned, ask questions, and then refine some of those needs like technical guidance or data and tools. And so we want to be doing this in a space where we're talking about basin characterization, but we're also having a cross-section of involvement with other programs like LunchMAR, as I mentioned, and different initiatives across the state that can benefit from a better understanding of the subsurface. And so that we can have those common tools, research questions, and data collected and made available for us all to use. So some of the specific goals we have for BCX are to really strengthen the collaboration that already exists and has been going on for many decades, but has really been a huge shift in momentum since the last decade of Sigma implementation. And we want that connection between all the different local, state, and federal agencies, researchers, academia, practitioners, and really importantly, the public, to make sure we're building that understanding of how critically important groundwater basins are to all of us in California. And then also a key goal for us is to, as mentioned, advance tools that we can all use, standard methodologies we can come together on, so we can really integrate our different efforts together and build off of our efforts and work with each other in a standardized way. And really to build that community of practice. So again, all of that's going to really allow us to tune how we develop the data, tools, and methodologies that we can do with the resources we have at the state. But again, that's only as effective as the applications and the use cases that we have to put those tools to use. So before I hand it over to Catherine, I just wanted to quickly highlight that within this basin characterization effort and this exchange of ideas, it's really connected to a lot of other big groundwater data collection or reporting activities, which are required again in the water code, which gives us a statutory foundation for this, and again has led to the resources that we've been able to bring to this effort. And one of the big flagship ones is California's Groundwater Bulletin 118. And we're required and have been required for a long time to publish this document. It dates back to the early 50s, and there's been periodic updates of Bulletin 118 or California's Groundwater over the years. And with the emphasis in groundwater in California and then the need to better understand that resource, we have been really improving the amount of information that's flowing out, and also compiling the information that's flowing in, so we can then organize it and get it out there so we have best available information to use. So the sort of the middle lane of activity that we have going is, we'll talk a lot more today, so I'll do a light touch on this. But as mentioned, DWR and many other local agencies and federal agencies have been doing basin characterization since the 20s in California. And there was a huge just level of action back in the 60s, 70s, and then there was a quiet period, more or less from the state perspective, I guess, involvement. But really, SGMA has changed the game, as we know. The statewide AEM surveys, you'll hear more, has really built that momentum, and we're continuing to build on that and do more and more as we can, again, tuned to the input that you provide and the needs that are out there across the groundwater community. And then also a lot of that data can feed into the Central Valley wide models that our team at DWR, C2B Sim Fine Grid or CVHM can utilize to be enhanced and have the best available information used. And then finally, what really the foundation of all this is the data collection. And so again, our regional offices, others across the state have been collecting groundwater levels, quality, subsidence data for decades. All this new geophysical data, water quality data, land use, you name it, all of that we're going to continue to make available, collect, steward, and report, and make publicly available. But that then feeds into characterization, and that feeds into the statewide updates. And then the most important part is getting access to this data. And so this exchange is our one way, one channel of information and feedback to get information out, but also do that in a way that different entities can consume that data, from the public, a more layperson type of data reporting, to more technical viewers like our SGMA data viewer and some of the new 3D, 2D, 3D data viewers that Catherine will share today. And then open data, which has been so important for all of us to make sure we share that information so it's all publicly available and useful and used. So I'll just end in that, again, we're required to do this in the water code. Just paraphrasing the water code, because I know the water code isn't that exciting, but it is in this case, because it says, in conjunction with other public agencies, DWR shall conduct investigations of the state's groundwater basins, and really do that in a way to understand the resource, and continue doing that and publishing it in Bulletin 118. And so that little part of the water code is really allowing us to continue this legacy effort that started back in the 60s when this came into the water code. And we want to be doing that with you all on the call today and others across the state. So I'll turn it over to Catherine to go over more details of AEM and basin characterization. So thank you.
Great. Okay, thank you, Stephen. Yeah, thank you, Stephen, for providing an overview of the BCX and also all of the activities occurring under the California's groundwater umbrella. And so I'm going to focus today on what's happening in the Basin Characterization Program, but I wanted to just take a minute to highlight what we accomplished in the statewide AEM surveys, because as you've heard, that really has been the impetus for us moving and launching into basin characterization. So just a light touch here. As a part of the statewide surveys, we collected about 16,000 line miles of data across 95 groundwater subbasins. And our goal with this work was really to improve the understanding of large-scale aquifer structures and to support the implementation of SGMA. And so we did perform a preliminary hydrogeologic interpretation of the AEM data, looking just at the shallow average of the textures in the shallow subsurface, getting a better understanding of potential groundwater recharge areas, looking at that same type of map of the average in the shallow subsurface, comparing it to known locations of alluvial fans of glaciated and non-glaciated origin, as defined by Graham, Fogg, and Gary Wiseman. Also looking at the texture model within the Central Valley, the AEM-derived texture model, so these fence diagrams, to help us better understand or see evidence for the geologic past that we know existed, and then also to see some of these larger aquifer structures that we suspected were there. We can also use it to look at seawater intrusion, so looking at the extent of seawater inward migration on coastal aquifers. So I think I covered that maybe in 30 seconds. This is, of course, is not our focus today. And if you're interested in learning more about these preliminary hydrogeologic interpretations, we do have an article coming out in the California Geologic Survey's relaunch of the California's Geology magazine. So that should be coming out in a few months here. So again, these preliminary interpretations were really focused on just the AEM data. And as Graham noted, it is really important for us to be looking at the entire picture of not just the AEM data, but also at these other data sets of lithology logs and geophysical logs and the known geology as well. So that leads us to the launch of our Basin Characterization Program. And so under Basin Characterization, there are really three main tiers of work that we're performing. That is conducting groundwater evaluations, where we're collecting, compiling, and digitizing data. The data analysis, so a way to process this data, and then developing maps and models that define various basin characteristics like aquifer recharge potential, or the texture, or aquifer storage, hydrostratigraphic properties, things like that. And we want these maps to be state-stewarded. So the state-stewarded component is really this infinity. I don't know if you can see my cursor here, but it's really this integration of all of these components together, so that once we create a map and model, that isn't necessarily the end of the story. If we continue to collect data, if we continue to digitize data, we then can go back and rerun these tools to update these maps and models so that we steward them so the latest models are available. Then, of course, a part of this work is always ensuring data access and visualization, and archiving all the data in California's groundwater, as Stephen mentioned. And additionally, the Basin Characterization Exchange, our opportunity to connect with the community of practice. Okay, so I'm going to talk a little bit about each one of these, but I'm going to start out focusing on these data analysis tools, because these are really the linchpin of everything that we're doing, and the heart really of this program. So the purpose here of creating these data analysis tools is that we have these large data sets now. We have the statewide AEM, we have thousands of digitized lithology logs, geophysical logs, and we're continuing to collect data as well, different geophysical data sets. So we need to have tools and processes that allow us to integrate these data sets together, utilize advanced computational analyses like AI and neural networks that are now capabilities within our systems, and then that are also reproducible, right? So that we can come back and someone else can obtain the same result. We want to use this to develop these state-stewarded maps and models like texture models, hydrostratigraphic models, aquifer flow parameters, things like that. And those are all components that will go into your groundwater flow model. If you're familiar with groundwater flow models like C2 VSIM or local. We're also working on developing process documents to also characterize various components. And the one I'm going to highlight today is a process document to create aquifer recharge potential maps, right? And so that's going to support recharge and flood management decisions. And I'm going to start on these first three maps and models that would go into a groundwater flow model. Just dive in a little bit more about what those tools are. So the first tool in this toolbox is a tool called Data to Texture. It creates a three-dimensional texture model. So a 3D texture model is this voxelized grid in a three-dimensional space where each one of these voxels has a value for the texture in the subsurface. And traditionally, texture models were developed using lithology logs and interpolating between them. And so the improvement or the new thing about data to texture is that it also integrates the AEM data. So now we can take the AEM data interpretation for texture and also utilize that in developing the three-dimensional texture model. We then have a suite of tools called Data to HSM. And this suite takes the texture model, it takes the AEM data, existing hydrogeologic or geologic interpretations, as well as other data sets to help derive the hydrostratigraphic model, so the layers of interest within the subsurface. Both of these can go into this texture to par tool. So if you're familiar with texture to par, the original one, there's now a version 2, which is able to integrate AEM data. And so this tool takes the texture model, the hydrostratigraphic model, measured aquifer flow parameters to provide aquifer flow parameters across the model grid. And all that information can go into your groundwater flow model. And good news, the team has been working to develop these suite of tools for years, really since we started the statewide AEM surveys. And so we are ready to have a beta launch to share these tools with the public at our May Basin Characterization Exchange meeting. And that will come with an invitation to test the tools. We then will have a full public launch of these tools in the fall. Okay, so moving on to aquifer recharge potential mapping. So what we're doing here is really defining a methodology, a standardized methodology to describe 3D aquifer infiltration pathways as 2D maps to support groundwater managers in prioritizing potential recharge locations. To date, what we've focused on is developing 3 types of maps. Shallow natural, which describes the pathways from the surface into the shallow portion of the aquifer through the soil layer. Preferential pathways, which describe pathways from the surface to a deeper portion of the aquifer through an incised valley fill or paleo valley. And 2 types of maps, one that assumes infiltration through the soil layer, and one that assumes that maybe the site has been built, that soil layer has been removed, and so we don't have to consider the soil layer. And then we will, coming soon, be exploring developing deep aquifer storage maps, which will really be focused on supporting defining areas for aquifer storage and recovery. So this aquifer recharge mapping process begins with gathering the data. So the data that are considered in this process are soil conditions. So we're getting information about the infiltration capacity through soils, depth to water. So getting information about how much storage capacity or empty pore space is available between the surface and the water table. And then 3 parameters that are obtained from the texture model. So that those include depth to a fine body. So that gives us information about if there's any limiting factors to downward downward flow. The average shallow coarseness. So what's that? What's the average coarseness in that shallow subsurface? And then interconnected coarse bodies. So a parameter to define where there is a continuous coarse body from the surface down to a deeper portion of the aquifer. So you gather all the data. The data are then ranked based on a variety of more suitable groundwater or more suitable recharge conditions versus less suitable recharge conditions for each one of these parameters. And then they're then weighed. So then each data set is then weighed to create a various map type. So for example, creating a shallow natural recharge map, soil conditions are weighed heavily, and the depth to the first fine grain layer, as well as shallow sediment coarseness and how much room is there in the aquifer. Whereas deep preferential pathways both really just focus on where these pathways are, so where these interconnected coarse bodies are located. And so after we've gathered the data, weighed it, we can create these aquifer recharge potential maps. So these are then a series of maps that describe recharge potential, where the higher the value, the darker the color, these are relatively more suitable locations for groundwater recharge. Again, we'll be working on developing these deep aquifer storage maps. And all of this process is written up in an aquifer recharge potential mapping process document. And we're getting very close to finalizing the draft version of that document, and it will be posted on the Open Data portal. And then we will be sharing the details of this process in the April BCX meeting, and also with an invitation to review this draft document. But just to know, all of these maps are a screening tool for parcel prioritization, and additional investigation is always recommended. Okay, so just highlighting a couple of the tools there, and I want to go into just describing some of these groundwater evaluations that we're conducting at both the local and the regional scale. And again, the purpose here is to be collecting data and exploring analysis techniques to develop state-stewarded maps and models that really support groundwater management. So we're looking to define various basin characteristics, texture models, interconnected surface waters, depth to basement, a variety of things. And we have various methodologies we can use, either the new collection of data or the digitization or reprocessing of existing data. So we can go out and collect infill AEM, we can collect ground-based electromagnetic data, either towed behind an ATV or behind a boat. We can collect advanced geophysical logs. We can collect traditional lithology logs, and even maybe reprocess seismic data. And so we have 3 local investigations underway. Those are in Madera and North Kings, where we'll be developing texture models, aquifer recharge potential maps, and investigating interconnected surface water. There's also Pajaro, where we're really mostly here focusing on supporting the locals and the work that they're doing. And their work really focuses on recharge potential and interconnected surface water. We are then working in the Western San Joaquin Valley, where we'll be developing a texture model, looking at the deep aquifer hydrostratigraphic model, and developing aquifer recharge maps. Again, here focusing also on that deep aquifer ASR map, and also looking at subsidence. We then have some regional investigations underway. And our goals here for the regional investigations are really focused on developing the texture model and the aquifer recharge potential maps. So we will be working in the Sac Valley, in this 4-county area of the San Joaquin Valley, which is right here in the center, just above Kings, and then also just the entire San Joaquin Valley. Really, fingers crossed here by the end of the year. So I'm going to focus on just 2 investigations. The Madera North Kings investigation and the Sacramento Valley investigation, just to give you a flavor of the type of work that we're doing. So the Madera North Kings local investigation, our area of interest here is really focused on this area north of Fresno and east of Madera. where we're looking to identify aquifer recharge potential to support domestic and deep well water supplies. So making these aquifer recharge potential maps, and then also characterizing the native material underneath the river system to improve the understanding of interconnected surface water and multi-benefit habitat restoration. It's just a little picture of what it looks like down here. And this work is really in, we're working closely with DWR's LunchMAR group, who's working on the Upper San Joaquin River on developing their ecological flood inundation potential tool, their EcoFIP tool, and then also working closely with the GSAs in this area on these recharge maps. So the process here is to collect the infill AEM, digitize additional lithology logs, develop this texture model that integrates the AEM data and the newly digitized lithology logs, create the recharge maps, and conduct field investigations. And so we've completed these first 3 tasks, and so I'll just give you a highlight of those. So again, as I mentioned before, we have the airborne electromagnetic interpretations for texture in this area. We also have the infill data. We also have loads and loads of additional digitized lithology logs. We don't highlight this enough, but as a part of the statewide AEM surveys, the team QA'd and QC'd thousands of lithology logs. So there are thousands of now digitized lithology logs with high location accuracy throughout the state. So we utilize that data set. We also additionally digitize additional lithology logs, QA/QC them specifically for this project. So we had over 2,000 lithology logs in addition to our AEM data. We input that into our data to texture tool, and we got out a high resolution texture model. So the resolution of this model is the horizontal grid is on the order of 30 acres, and then the vertical resolution is on the order of 15 feet. So if you're familiar with texture models, it's a pretty high resolution texture model with a depth down to 400 feet, because really here we're focused on the shallow recharge potential. So we then input that texture model into our aquifer recharge potential mapping process, and we were able to develop these aquifer recharge potential maps for the Madera area. For the Madera North Kings area, where again, these darker colors are areas that have relatively higher potential for recharge. So we're, but as I mentioned, these are a screening tool, and it's really important to have additional investigation. So what we're doing now is we're working with the GSA to prioritize some of these parcels that have expressed interest in recharge and have higher aquifer recharge potential values. So now we can narrow down the areas that we want to focus on. And on those parcels, we can go in and collect totem data to better understand if there were any fine scale features that we weren't able to capture in the texture model that would inhibit downward flow, that would inhibit recharge. So that is the plan there. We'll also then be working with the GSAs and our LunchMAR group to define high priority sections of the Upper San Joaquin River to go down and collect flow TEM data to better understand the distribution of the materials beneath the river system. So lots going on there. Quickly moving on to the Sacramento Valley. The goal of our work here is to be supporting the GSAs in identifying potential locations to recharge to support domestic wells, deep well water supply, and also subsidence management. So a little bit, a pretty similar order of tasks, but a little bit different here. We first want to develop the texture model using the existing high quality digitized data, develop the aquifer recharge potential map with that existing data. Then as we'll have the preliminary map out, we want to continue to digitize additional lithology logs in this area to create step 4, the revised texture model that then integrates the AEM data and those additional digitized lithology logs, and then come out with another aquifer recharge potential map. So this is really highlights that infinity loop of work to do, where we want to be putting out the best available information we have now, but that doesn't mean it's the end, and we're going to continue to digitize data and continue to refine these maps and models as we're able to get more data into there and analyzed. So we've in this area preliminarily have finished the first two steps. So I'm going to share those with you. So we have an updated texture model in this area that was, again, developed using the same lithology logs that were used to develop the SV-SIM texture model. Again, this doesn't include AEM data at this time. The horizontal grid of this mile is about a fifth of this grid is about a fifth of a mile, with high resolution about 15 feet deep. And then we go to a total depth of about 385 feet. This is a preliminary model, still more work to do and coordination to have with the local agencies. But now that we have that model, we have those other data sets, we can develop the aquifer recharge potential maps. I'm just flashing this up here very quickly to let you know that we have preliminary maps. We are moving forward with this, but I'm not ready to share them today. So stand by to see these Sacramento Valley maps come out very soon to be shared. Okay, so where can you access all of this data and tools and information that we've been covering? So you should go to the California Natural Resource Agency Open Data Portal Basin Characterization Program page. Here you can, if you're interested in a local area, you can click on Madera and North Kings and you'd be able to find the texture model here, as well as the aquifer recharge potential maps. And the same data for the regional investigations. You can also get here under analysis tools and process documents, more information about the tools I mentioned today, and then also some of the data visualization that I'm going to show you in these next slides. So this is where you can access all the raw data or the documents. But we have made some updates to data visualization, specifically here on the Sigma data viewer. We've added this basin characterization tab, and down here, under airborne electromagnetic data, you can click on a profile and you can view the profile images from the data reports, the AEM data reports here on the Sigma data viewer, so you don't have to open a report to see a figure. We have the aquifer recharge potential maps also on the Sigma data viewer, so you can look at those. Currently, we only have them for Madera and North Kings. We also have the texture model that we developed. So this is showing depth slices of the texture model in feet. And so you can go through and examine, see some cool things with where some of these channels might be located. So very interesting indeed. We also, of course, have our AEM 3D viewer, which continues to be a great resource to examine the data in 3D space. And I wanted to share a viewer that we have most recently launched, and that is our subsurface viewer. It is under development, so please be patient with us as we work through bugs. But what's great about this tool is as you go across these profiles,
Anyone else
Looks
losing
like,
Catherine?
yeah, I'm losing Catherine.
uh-oh.
Oh, you there, Catherine?
There she is.
Can you hear me?
Might be back.
Am I here?
Yep, we can hear you. Yeah, and keep
Can
rolling.
you see? Okay,
right.
okay. Let me play this video again. Can you see this video?
Yes.
Okay. Maybe my computer can only handle so much. So this little video is just showing that as you move across the profile, this is showing the coarse fraction data. You can see where you are on the map and start to pinpoint, if you're standing here, what the texture is like in the subsurface. So there's also a feedback button. If you'd like to give us feedback on this, please do. We're looking to, of course, always improve our data viewers, but again, be patient with us because we are working through some glitches on this viewer. So for timeline, we are just, it seems like pedal to the metal, just getting lots of work done over the next year. So continue working on these texture models and aquifer recharge potential maps for the local and regional investigations that I mentioned. And then also working to get out the various process documents, analysis tools, data viewers, California's groundwater, out, and then ending the year hopefully with these maps, the aquifer recharge potential maps of the entire Central Valley, and then working on next year into developing the HCM for the Central Valley. Okay, so that was quite a lot of time of me talking, but I try to cover a lot of topics in a really short amount of time. So if you're interested in hearing more about the aquifer recharge potential maps, we will be presenting that at the April 22nd BCX meeting. The data analysis tools, if you'd like to have early access to testing those tools and providing input, please join us for the May 20th meeting. The meeting registration links will be sent out via our listserv, so you can use this link here to register for the listserv, or you can scan that QR code there. But please register to get the registration links. We'll also be sharing the Basin Characterization Exchange Hub site with the BCX listserv, where we'll have our schedule. We'll also host meeting recordings and presentation slides, and then also relevant publication information. Okay, so with that, I think Megan has a poll for you guys, because we're really interested in making, I think as Stephen mentioned, in making this BCX a community spot for us to interact and engage on the work that you guys are doing and the work that we're doing. So I think the poll has questions like, what topics would you like to see covered at a future BCX meeting? And are you interested in presenting at a meeting, or would you like to see a colleague present?
Okay, ready to launch?
Yes, thank you.
Here it goes. It's another two-parter, and there is some scrolling involved.
It's a long one.
So the first one is select all that apply to you. The topics, the different basin characterization related topics that you're interested to see, Catherine just mentioned. So we pre-populated many options. If you're interested in them all, click them all. If we miss something, please describe what you would like to see in the chat box. Question 2, are you interested to share information about your work, or do you know of a colleague to nominate for future BCX presentations? If yes, also you can do, I think, a short answer response in the Zoom poll here, or you can also use chat.
And while you're filling that out, you can always also email us at basin.characterization basin.characterization@waterca.gov if you're interested in presenting, or you know anyone who would like to present. So with that, I want to say thank you all for sitting through this long, feels like quite long presentation, and also a big thanks to the LunchMAR and the FloodMAR network for allowing us to engage with your great audience. You guys have really built an inspirational network, and we're so happy that we could be a part of it and connect with you guys through launching the Basin Characterization Exchange.
Wow,
Okay,
look
so
at that.
let's leave the poll open. And if the poll is bothering anyone, you can always exit out with a little red dot. But I'm just going to leave the poll open in case other folks want to respond here. You're still thinking about it while we take some questions. So Graham, go ahead and lead us in some Q&A.
We have a number of questions in the chat box. You can always raise your hand and unmute. Patty Piori, sorry if I mispronounced your name. Will this data allow to update the Bulletin 118 basins to assist in Sigma implementation going forward?
Yeah, I can take that one. Thank you, Patty, for the question. Yeah, the answer is yes. The existing basin characterization and new basin characterization data that will be available can be used as supporting information for future basin boundary adjustments. That is part of a regulatory modification process. And so when those windows for basin modifications are open, that would be the time for that data to be compiled and presented to justify any basin boundary modification. So currently there's no basin boundary modification window open, but when it would in the future, that data could be used.
And Christina Buck has the comment and question. Many local agencies / GSAs are installing shallow monitoring wells with SGM grant funds to improve understanding of water table conditions. What would be the time frame of updating the recharge mapping with newly available data?
Yeah, another great question. And I'll take a first crack, and Catherine, if you want to add anything. So we're learning by doing right now, Christina. And so we're trying to understand, what does it take? What level of effort does it take to compile and crank the wheel to get results that come out? And so as we get a better definition of the resources that takes, it's really going to refine how often we can do that as our team. But one of the fundamental principles we have is that, we DWR want to be providing tools and the data that come out of those tools, but also the tools themselves. So, your GSA or other local entities can take that tool set, apply it to your local database, and run it whenever you want. And so there's going to be a way to have our version of the results that we'll be doing. And if there's local capacity to crank through those tools on your own with your data sets, you'll be able to do that as well. So sort of crowdsourcing and making that available. But we are very interested in, if there is data, as we know there is across the state, we would like to work with you all and have that come in to inform when we do make those periodic updates to, let's say, the Central Valley 3D texture model or aquifer recharge maps. So Catherine, anything you'd want to add there?
Yeah, no, I think you really hit the nail on the head. It's really important to, when we do reach out, which we will do, reach out for data to support in creating the aquifer recharge potential maps or lithology logs that we can put into creating the texture model, that if you have that information, to share it, because then we will integrate it into the most recent product that we have. And as Stephen said, I think to be determined what the correct time frame will be to recrank the wheel, how much additional data we have so that it makes sense. But we do plan to recrank the wheel.
Thank you. Patty Poirier asks, as you investigate the ability to recharge, is there a consideration of the water quality below the surface?
So very important question and topic. There's a lot of effort going in on that. So at the moment, we're looking at more of the physical characterization or characteristics of the subsurface. But that is something that our team is discussing and integrated into some efforts that Sustainable Conservation is doing to look into that, and others. And we're also working, colleagues on the call today and in our team are working with groups to try and get more water quality samples in and around areas that flood or do manage aquifer recharge. So with a combination of all those things, we do plan to move into that realm of water quality, but we're not there yet. But we know that once we know the physical characteristics of the basins, we then need to be looking at the geochemistry and geochemical characterization. But that's a complex world, and but an important next step.
Good points. Jason Weiner asks, based on these local and regional investigations that appear to include validation of the aquifer recharge potential maps and other validation or recharge projects that have occurred, do you have a sense for the accuracy of the aquifer recharge potential mapping?
Yeah, really good question.
Or let me ask a
Yeah.
similar question this
Yeah.
way. Would a recharge potential of 2 versus a rating of 4 make or break a recharge project decision-making process?
Yeah, and I think that's where the strength of this BCX and local partnerships and testing things out is going to be important. What we're trying to provide is a relative range in what Catherine presented. And so it's really less about the actual number, but more about the trend, or the where that shows up across the landscape. So I think, yeah, that's where we'll need to learn more. We have efforts in certain pilot areas where we can couple that recharge potential with monitoring and actually get empirical data to understand real world actions and how real world conditions change from that. And then again, our team, we have a very great modeling team within DWR that maybe down the road we can explore that more. But yeah, anything else you want to add there, Catherine? Or Jason, if you want to come off mute.
Oh, no, I just wanted to say I really appreciate the data and the tool. That comment's not meant to undermine any of this. I think the work is superb. I'm really excited to, dig into that, technical document that you provided, and use these data. So no, just thank you.
That's great.
Thank you for
Yeah.
the hard work you and your team are doing. It's really great.
You bet. And thanks for being here and part of the BCX.
And Rick, go ahead.
So I'll just add on to that, and that really is the crux of this, is that also these are potential maps, right? So not necessarily a defined value. And so that is another reason why I did really want to highlight that it is going to be important to also go in and do higher resolution surveys. So we're not, of course, at this point doing infiltration surveys to see what the actual infiltration rate would be, but just to see if there are any limiting factors that would inhibit downward flow. And that is a really important component that we will be testing out in this Madera area here coming.
Yeah, and it seems like a lot of this is living, and that's the beauty of doing this outreach and the broader outreach that the BCX is doing, is you connect with, folks here who are doing these projects, have these data, and hopefully can feed that information to you, and collaboratively we'll just make these tools better and better.
Yep, that's
I
it.
think it could be important to remember that you could, in a place like the Central Valley, you could almost recharge anywhere, even in the Yolo bypass behind me, where there's a lot of clay. But there's a lot of recharge happening there now. The subsurface data confirms that. So it's just that in places like this, it's slow recharge. So you may need those recharge maps mainly to identify the big whopper potential recharge sites where you need to put a lot of water away quickly because you don't have the real estate to spread the water over big areas.
Yeah, and then really start to couple that with available water,
right,
and infrastructure to get it to these places.
Right.
Yeah.
So another question here. I think we still have time. Is that right, Megan?
Yeah, maybe checking in on time real
I
quick.
just wrote in the chat an acknowledgement that we're at the end of our scheduled hour together, but we coordinated beforehand. Stephen and Catherine were okay to go a little over with us, knowing that this is going to be a popular topic. So we're going to keep the recording going. And if you have to hop off, no problem. But I think we can take a couple more questions, and then all of the conversation will be part of the recording that gets posted.
Stephen and Catherine are generous enough that they said that they'll be here for at least till 5 today. So if you really want to dig in.
Too much good stuff. Yep.
Moving along, Rick Iger, does texture mapping pick up compacted soil that might interfere with recharge, i.e. at the till zone?
So that would be in the top foot or so, or in that area. So I didn't mention that in these groundwater or in these texture models that we've developed, the average is 15 feet in the subsurface, except our top layer, which is a 1 foot, has a 1 foot depth interval size. So it's a very, very shallow top layer. So depending on the information that we're getting from the lithology logs, if the lithology logs did capture that layer, then that compacted soil layer, then it may be captured in the texture model. Otherwise, it would be hopefully captured in the SAGB data set, which would be integrated into this aquifer recharge potential mapping process.
Yeah, on that note, I think it's also still important to be on the lookout for where and whether you can map the paleosols. The work done in the past by Wiseman and myself on paleosol sequence stratigraphy of the fans, especially on the east side of the Central Valley, and those paleosol roles in segregating different parts of the aquifer system could be very important. Those, as you know, recharge limiting layers go, the buried paleosols may turn out to be the most important things, maybe even more important than the Corcoran clay. So enough from me on that. Let's see. Let's go. Byron Emerson asks, what is the minimum modeling domain size that these data are intended for? In other words, what size study is too small for the resolution of the texture model before needing to collect higher resolution data? It's a good scale question. Anybody?
So I'm not well, I'll just say I'm not exactly sure if we're talking about the scale here on the parcel size or the scale with depth. So I'll just maybe note a couple facts about the resolution.
Say in your texture maps, you know, how local do you think the scale gets in those? And I know it depends on the coverage of borehole data in many cases also, right?
Right. So we do have a minimum requirement of boreholes that we use, which which are 2 boreholes per public square per square mile. And then we are interpolating over the distance between those boreholes on a higher resolution scale. Also integrating the AEM data though, so that helps to fill the gaps between some of the distance there. But I would say that what we're seeing in the Madera and North Kings area is that we are looking at maps that are on the parcel size, that are getting estimates on the parcel size horizontal spatial grid. Now the vertical grid, again, I mean, it's really weighing out how high of a resolution that you want to make in that vertical grid space. The higher resolution you have, the more likely you are to capture some of those clay layers or those layers that would inhibit downward flow. But it becomes unwieldy to have a grid space with 400 layers and over a textual, the area we're investigating. So we found that this 15-foot interval would help to be kind of this space in between. We may find that we want to that it's going to be important to increase the resolution of that vertical, the resolution in the vertical text space of that texture model, but I think still to be determined.
Okay, and I think that at least partly answers E. Geyser's question about vertical layer thicknesses. Looks like one last question here from Todd Green. Todd says, in my experience, AEM is only as good as the calibration to wells. How much is the AEM data calibrated to individual wells versus using a histogram of AEM responses from wells used from a large region?
Okay, so I think this is about the AEM data interpretation for texture as a part of the statewide AEM surveys. And so as a part of that project, I didn't go into the details at all today, but the team did go through a pretty hefty interpretation process where the AEM data were interpreted using high quality digitized lithology logs. So the locations of the lithology logs were defined within a 50-meter buffer, were defined within 50 meters, and then also the quality of the well was investigated so that we were only using high quality wells. And so again, for the AEM project, they used 2 wells per public square mile, as came out as a recommendation from the AEM pilot studies that were conducted before the project kicked off. And so I think in some places where there were enough lithology logs and information that a good relationship was able to be defined in interpreting the electrical resistivity for lithology. Of course, in areas where there were no lithology logs that existed to calibrate the data, there might be some higher uncertainty in those areas. But I think in general in the Central Valley, there were a lot of areas that had good where there were a lot of wells that we were able to calibrate or transform the AEM data for texture.
And Rick Iger also asked, will there be an opportunity to meet with local experts before maps are published? Of particular concern would be Corcoran clay areal extent and depth.
Yeah, good question. And that gets into the outreach that we'd like to have in these sessions, and then more specific outreach with specific entities. And so we do want to get that feedback about local sensitivities to results that would be coming out. And so if you have additional information on that, Rick, that would be really helpful. But we are trying to get information out as it's available, and always caveating that it's draft or whatever vintage it is and the assumptions that have gone into it. So we know that as DWR, when we put things out, it has maybe a little bit different standing than something else. And so we're trying to acknowledge that, but really looking for feedback on how that lands at a local level and some of the sensitivities that are there or might be there. So that'll help us move forward in the most appropriate way.
And a comment from Kamir Gavechi, great presentation and accomplishments. It would be helpful to identify, so everyone's got the but at the end, right? Okay. It would be helpful, just needling Kamir a little bit there. It would be helpful to identify water/land use planning efforts that would benefit from the BCX data, tools, and products, such as the MLRP Land Repurposing Program and CVFPP update, which are two of many, and to package and serve up the BCX data products to support their use cases.
Yes, great point. And that's something that really in the BCX here and additional input that we have been getting and would like to continue to seek is what are all those different connection points or case studies. We are compiling a list of those and have been working to integrate this basin characterization data, the 3D texture models, the aquifer recharge potential maps. As soon as they come out and are available, we're trying to test to see how they would overlay with some of these other efforts, but that's very preliminary right now. So the more that we can get that list, to Kamir's point, it's going to allow us to see what connection points, and again, the strong connection we would like to continue on with the LunchMAR network, because there's a lot of use cases at multiple scales that we can be integrating this new data in and informing how we continue to advance our data and tools so it's most applicable for as many of the use cases as we can do.
And one more, Mark D asks, is NASA GRACE data used?
Hit on that one, Catherine?
Do you want to cover maybe how it's being used for storage estimates?
Oh, yeah, for sure. Yeah, so it's not used in this current suite of tools that we described today, but more generally, it is being used as we develop Bulletin 118 Update 2025 to compare the GRACE change in storage data alongside the regional Central Valley modules and some work that our team members have been doing with groundwater level change in storage analysis that has been in previous water plans and Bulletin 118. So it's really neat to see how those different methodologies and data sets and time histories match up. And so that will be a really neat new content that our colleague Bill Brewster in our North Central Region office and team have been working with JT Rieger at NASA JPL on. And so that'll be out in the draft, and look forward to any comments you have or others have on that and where we go forward with integrating different change in storage methodologies or different NASA-based satellite products that we could continue to integrate in California.
I'd point out that another promising method for storage change calculations is gravity, local microgravity. So same principle as GRACE, but data collected at a scale that's more like a watershed scale. So it eliminates the huge footprint problems of GRACE. USGS has been using gravity surveys, these special gravity surveys in Arizona and elsewhere with some success, I think. So that may be another one to look into that could turn out to be relatively economical too.
Yep. Thanks for adding that, Graham.
Okay, wonderful. And from the comments in the comments section, there's a lot of enthusiasm and pleased listeners here. So thank you so much for a most informative presentation and for staying around for some overtime work on answering all the questions.
You bet. Yeah. And thank you, Graham, again, for all the work you've done over the years to get us to where we are and provide a great launching off point. And just thank you, everyone, for being part of this initial launch of the BCX, and really looking forward to continued coordination and engagement and having you all share your ideas. So again, if, as Catherine mentioned, if you have colleagues, or if you yourself want to be a featured speaker at an upcoming BCX, please let us know, because the value of this new venue that we're creating here is only as strong as the membership and the willingness to share. So let's all lean in and try and share as much as we can and utilize this venue. So I think with that, we can sign off here. And again, if there's any other questions that come up, please email us at that Basin Characterization email. All right. Take care, all.
Thank
Bye.
you so much.
Thanks, Graham. Thanks, everyone. Bye-bye.
Bye-bye.